Hello everyone, this is the third part of videos for the activity we did in class on Friday, and the question was to find the limit as x approaches -1 of a piecewise function. And to begin with this, I just want to point out that to find the limit as x approaches -1, we first need to find the limits from the left, which we notate with a superscript negative, and find also the limit as x approaches -1 from the right side, which we denote with the positive superscript, and compare those two values if they are equal to each other. This is the only time that the limit at the point -1 exists. So let's start with the first limit, and I will do them in different colors. So limit as x approaches -1 from the left means that the values that we are looking at are less than -1, which will take us in this part of the piecewise function. And then our function would be this one right here, which is -x minus 2. Substituting x with -1, we get minus -1 minus 2, which simplifies to 1 minus 2, which is just -1. So now let's see, as we are approaching on the right side, which is limit as x approaches -1 with a superscript plus, which will take us to values that are greater than -1, and this is the case here for the piecewise function. And our function looks like x to the third, and substituting -1 for x would give us -1 to the third, which is -1. We see right away that those two values here and here are equal to each other. Then we can conclude that since the limit as x approaches -1 from the left is equal to the limit as x approaches -1 from the right is equal to -1, then the limit at the point -1 exists, and it's equal to that value here. So now you might have a question, what about that part over here when x is actually equal to 1? So when we're finding limits, we're always looking as the values get closer and closer to 1, but not exactly at -1. And I actually graphed this piecewise function, and I'll show you how it looks like and how to find the limit. So if we come right over here, you can see that I actually graphed the function. So we have the first part. If x is less than -1, we have the function -x minus 2, which is a line with negative slope, which is right here. Once we go to x equal to -1, the value of the function was 2, which you can see it's right up here. So when x is -1, the value for the function is a 2. And then once we go to any value that is greater than -1, we jump to the cubic function, and we start at -1 and continue with the cubic function. And actually at -1, right at the value -1, we have a hole, and it jumps right over here. So let's look now at the limit. So we are saying as our x values, sorry about that, As our x values get closer and closer to 1, how are our y values behaving from the left side? So we are looking here and we see that our y value gets closer and closer to -1, but it does not reach it. We only care about the values that are closer. So we see here that it approaches -1. And if we look for the values that are bigger from the right side, so x is getting closer and closer, so maybe we are somewhere here. If we look at the y value, we see that we get closer and closer again to -1. Because those two meet at -1, even though the value is not right here, we have a hole. But as we're getting closer and closer, they meet at the same spot. We can conclude that the value of the limit exists and it is -1. And I'll jump back to the notes to show you once again how did we solve this question. So that was it for the third and final question. Feel free to email me or come to office hours if you didn't understand any of the questions or you have any questions about the homework. Have a nice day.